So as you can see in the question, the photograph shows how the separate path of a light produced two images of an object behind the sample. So two images are produced behind the sample. When a polarizing filter is placed on the sample, so when we place a polarizing filter, as shown in the photograph, only one image will be seen, like we will only see one image. Explain why only one image is seen and describe what would be seen as a filter is rotated through 360. So first thing, because right now we are looking at these two images. And if we rotate the polarizing filter, so as two images are seen, one is basically due to the refraction, the light which is directly refracted. So it is having both components. Like there is actually a horizontal component will be there and there will be a vertical component. Now we are using a polarizing filter and we are rotating this polarizing filter first by 90, then by 180, then by 270 until 360. And we have to explain our observations like what we will see or what we will observe. So the idea is that the light is not transmitted, like we will not see any light when the plane of the polarizing filter is perpendicular to, like if the light which is coming out and the plane of the perpendicular this polarizing filter perpendicular, then there will be no light. But if the plane is parallel, means we will see the light. So first we'll use a concept that when the light is not transmitted when the plane or the direction at 90 degree to the plane of polarizing filter, and rays from each image are polarized at different planes. Like example one of the, as we are seeing two images, what is the reason for two images? It means that they have different components. That's why we are able to see two images. Otherwise, there should be only one image. So rays which are coming out from each image are polarized in different planes. Like maybe the first image, the image one, which we are seeing is due to vertical polarized. The image two, which we are seeing is might be due to horizontal polarized, and both light which enter our eye and we are able to see the two images. So when the polarizing filter, we rotate this polarizing filter, the image become fainter. Because why the image become fainter? As we rotate the polarizing filter, only one component will able to pass through. Or when the polarizing filter rotated, the image become, or rotated, the other image become visible, like we'll see only one of the image. So example, say we started the points which we should include and then the angle which we will mention, the points, the explanation which we include. Number one, like the first point, so there will be no light when the plane is 90 degree to the direction of polarizing filter. So when the polarizing filters are 90 degree, or that time it will not allow the light to pass through. Right now we are able to, without a polarizer, we are able to see both images. But once we place a polarizer and try to rotate, we'll see only single image. because one of the image which is having a component perpendicular to the plane, that won't be seen, the other image will be seen. So if I'm saying this as image 1 example and this as image 2. So the rays which are from the, because we are seeing two images, so rays which are transmitted or coming out, or rays of each image is polarized in different direction, and when we rotate the polarizing filter, the image become fainter. And what is the reason for that? Because only one component of the light is able to pass through. Now when we work out at what angle, so example, we started like this is a starting way. So when we start in this manner, which image will be seen? When the plane of the polarizing filter are parallel to the image 2. So at in the beginning, when the polarizing filter is placed, so which image will be seen? We'll see only, like we have image 1 and image 2 and the angle of rotation theta. I should write it theta first because that is what we do. So example theta, the angle. So in the beginning, the angle is 0. So which image, when we place or when we see this light through a polarizing filter, which image we will be able to see? As example, if we take the originally it is horizontal. So we are able to see image 2 will be seen, but image 1 won't be because its plane is in a different manner. Then when we rotate 90, when we rotate 90 means what will happen? So 90 degrees like this, the rotation. So at 90, as you can see, now the plane are parallel to image 1. So image 1 will be seen, but image 2 we cannot see because it's now perpendicular to the plane. Then we rotate further 90, like make it 180. Again, what will happen? Image 1 will disappear and image 2 will be seen. So at 90, like only the other image is seen. At 180, again we'll see the first image, and then at 270 we'll see the other image, and then again at 360 we'll see the, and between the angles we'll see both images, because if when the plane are perpendicular, then only we'll not see any image. Is it clear, this question, that how we use a polarizing filter to see the two images which are having uh, the pole light or emitting out or reflecting a polarized light which is at different components or direction? Then question 4, films made to watch 3D or 3 dimension are produced by projecting two slightly different images on the screen, and one of being seen by each eye. Basically, maybe you have experience of watching a movie in a 3D theater. So in a 3D theater, what they give you? They give you special type of glasses. Basically, what are these glasses? these glasses are actually polarizing filter. So what happened? One of the filter is having a horizontal polarizer and another one is vertical polarizer. Like example, on the left eye, if it is horizontal, on the right eye, it will be vertical, or it can be other way around. So example, these are the polarizing filter. Now, what happened? The light which is projected on the screen, the image which is projected on the screen, and that enter your eye. So basically, they're projecting two different images. So when they project two different images, and these images, they, like using a projector, it strike the screen and then bounce back and enter our eye. So there are two different images, as because there are two different images, but how they project these two different images, or we are able to see these a 3D effect. Basically, one of them, they have a horizontal component. So one is horizontal and another one is vertical. So when they reflect and enter our eye, so the horizontal component will pass and the vertical component is passed, and on our retina it will create two images which overlap with each other, and as a result it will give a 3D effect. Because the 2D effect, the object can move in x direction and y direction, but in 3D effect the object can also move in z direction, it means in and out. So the two dimension images, like one of the image, they're sending in a horizontal component, another image they're sending as a vertical component, and the polarizing glasses are there. If we use a polarizing glasses, so one of our eyes recording the horizontal component, the other is recording the vertical component, and the two images overlap, and as a result we'll see a 3D image. But what if you were not having, like another person is not using a 3D glasses and he's watching a 3D movie, then what happened? He will see two images but not clear. Why it is not clear? Because what happened, the two images will directly enter his eye. There is a horizontal component also and vertical component also, so that the image cannot process this type of uh, the eye or the brain cannot process this type of image which is having two components together. So it will appear to be very bright and it will appear to be blur as well, because like two images are forming in this both eyes. Like here, if you have a left eye or right eye, at the retina both components are there. But here what happened, one of the eyes capturing the horizontal component, another one is capturing a vertical component, and when they process, the brain processes this image, it appear to be a 3D. So what is meant by a plane polarized light? What is the definition of a plane polarized light? So again, when they ask for plane polarized light, so you have to use the term plane here, that light which is having a single or oscillation or vibration is in one plane only, and that plane include the direction of propagation. Because they ask for plane, so you should use the term plane here. So light which is having one plane of vibration which include the direction of propagation. The second part, the light from the screen reaching the eye passes through the filter so that each eye see the different image, and the filter on one eye is placed at 45, another one is 135. Explain this choice. So if one of the filter is at a 45 angle, the other filter is at 135. It means what is the difference between them? The difference in the angle is 90. It means if, like example, this is 45, so this is a 45-degree polarizer, then 135-degree polarizer will be like this. So what happened? Why? What is the choice? What is the reason why we choose these angles? Why not like any other angle? So it means when we are selecting 45 and 35, so the angle difference between the two polarizing filter are 90. So light from one filter will be blocked by the other filter. So light aligned or intended for one filter cannot transmit through the second filter. So when we write the answer, we'll mention the angle difference is 90. So light from one filter cannot pass through the second filter, as there the plane of the filter is perpendicular to component of light. Is it clear? Part B, that why we select these, because we don't want, if the light is able to pass through filter 1, that light should not be able to pass through filter 2. So if this light is able to pass through filter 1, this light cannot pass through filter 2, because otherwise what will happen, the same image will be formed in both eyes, and that it will appear to be blurred, because both components will pass. But we want one component of a light to pass through filter 1 and the second component of the light to pass through filter 2, and the brain will process the image and it will create a 3D image. Then one complaint is there about these 3D films seen through a polarizing filter, as they appear dark compared to ordinary films. Like when we are using a 3D glasses, it appeared that these films appear to be very dark. What is the reason for that? Because the light which is passing through the polarizing filter is a polarized light, and it is having only one component which reduces the intensity. So polarized light stop the most of the component, only allow or transmit one radiation to pass, one component to pass. So light from polarizing filter has one component which reduce the intensity, because that's why, like example, using a polarizing sunglasses, it appear to be much darker surrounding as compared to normal, because as we are seeing, the without sunglasses there are many component of vibration, and so many component are entering our eye which make it bright. But if we are using a polarizing sunglasses, only one component is able to pass. That's why ultimately the intensity will reduce. The 3D viewing is no longer done with the plain polarized glasses, because these require a viewer to keep their heads exactly level for whole film. Tilt of a head cause a partial viewing of left image by right, and vice versa. Explain why one eye would see a faint image intent for the other if the head is slightly tilted. Like example, this is also a constraint. Like if you are using a 3D glasses, there's a constraint. What is a constraint here? That when we are using a 3D glasses, we should always look, the head should not be tilted, it should be exact level for the whole film. Because if the head is slightly tilted, means, like example, so if a person watching a movie and he tilted his head, this manner, he's getting a clear image. But in this manner, it appeared to be faint. What is the reason for that? Because what happened? There's a horizontal component and vertical component. The horizontal component is passed through one and the vertical component is passes through the other. So a person is able to see it clearly. But what happened here? You can see light is coming in the same vibration, but the component which are there, the plane is not exactly parallel to the component horizontal or vertical. So as a result, what will happen, a small component of a light is able to pass through. So angle between the filter or the eye or polarized light has changed. Like, oh, first it was 90, but now it is not 90. So light for a one eye has a component in the other, because when the plane are exactly perpendicular, then no light is able to pass through. But if it is not exactly, some of the light is able to pass through. So what happened? Even though it is horizontal in this manner, so horizontal component is passing and there is also another component is there. Same way, this is vertical, so the vertical component is passing, and then again there is also another component. So you can see when a person tilted, the light from one eye has a component in the plane of a polarization of other filter, and angle between one filter and the plane polarized light has changed. It is intended to be 90, but now it is not 90. That's why we'll see a blur image. Is it clear? Or faint image? So this was about the polarization. The next session will do more questions related to the topic. So assignment, polarization.